So the project I made was Terrawalk AI, and so I was inspired to make this project um because I saw videos of humanoid robots walking on the internet, and like I noticed they fell down on steep terrain or terrain that was like not straight. So Terrawalk AI is a user-friendly platform where people can simulate like the real physics of how like whether it'll fall down or stay walking. So this is my the problem statement that we build the application around. So when companies testing bipedal humanoids try to make them walk straight on rugged terrain, they couldn't keep their balance and often fell down. So here's some real world insights about humanoids. Um, they're rapidly joining the industry, so the market share is increasing heavily in humanoids, and it's even in the medical field, which uh, disproves the misconception that robots will only transform like menial jobs because the medical field is very complicated and robots are doing a lot of work there too. So as you can see here, we enter a command for the robot and it'll move. And here's some, so it'll use a Grok API key. That's how we tell the robot to move, and it can fall down due to angle or falling in the void, as you'll see later. It can climb steep obstacles also, and you can sign up and log in with, and it's all built with realistic physics. So I'm going to demonstrate it now. Apologies.
No, that's totally fine.
So here's the application itself, and this is the home page. It just describes like what it is, and here are some mechanisms that are used in the application. Uh, a spherical inverted pendulum, Grokino transversal, and capture point telemetry. So over here, this is where the main functionality is, but right here we can generate new terrain. It can be very spiky or very flat. So let's try this one. So it's very spiky. So let's try to walk forward. They will climb this sledge and it'll stop because of the object. So let's tell it to, it'll jump around the object. It'll keep trying to find a space to jump safely. So it cleared the obstacle and it's just gonna keep walking. So let's tell us to walk around this one, for example. It'll calculate the trajectory that's safe and it'll walk. It also, if you notice, it bends its hips to keep balance.
All right. Is there any other functionality that you would like to show?
Uh, yes. So there's like a chat bot down here where you can ask questions. So here's like explanations on all of this. This is like to represent the rotations of the torso.
Okay.
Uh, and this like calculates the max, like the max threshold for each part of the movement.
Got it.
And this is how like it actually works. So when you enter your command, it sends it to the API and the AI, and it provides the output, and then clean clean that output into a JSON 3.2, and then it gets sent back to the program where you see the action.
Got it.
A- And these are just safety features for that.
Yeah.
Yeah,
Okay.
that's
Yeah, I've understood the project, and it looks really good, and the visualization is also really great. So I have just few questions for you. You can stop sharing the screen now. So my question to you is, how accurate is it right now? Like right now, it's not physically that accurate, right? So how accurate is it, and how can you make it accurate?
so I'm thinking of like integrating a so obviously it's not accurate right now because
Mhm.
it's just relying on like what's around it and trying to make the calculation in real time in the front
Yeah,
end. But I think to make it faster, we have to add like built-in physics in the back end so it can calculate it quickly and it'll be more accurate.
exactly.
Learning.
And my other question to you is, uh, like, what are the use cases for this? And the one use case that I see is it can be really beneficial in research side, right? Where you have to run a lot of simulations around robotics. So, what else use cases that you see in industry of a program like this?
So there it could also like spark interest for people who are not
Mhm.
looking to simulate but just looking to see like how a humanoid works because there's the two information pages like explains the math and the physics behind it.
Okay, yeah, that's interesting. Uh, uh, that's, I mean, I don't have any more questions for you, but the program looks really good. You can definitely work on it more, and you can make it more user friendly as well. If you're leaning towards, making it a gateway for other people to explore robotics and humanoid robots. So you can try that. And do you have plans to work on this project further?
Yes, for sure. I want to like expand it, make it more accurate.
Okay, that's really nice. So, what other features or like changes would you like to make in this product?
I was thinking of like um implementing a physics engine. Like
Mhm.
I was researching and I could like integrate my code into a physics engine so it becomes more accurate, the simulation.
Okay, yeah, that's a really great choice. Yeah, do you have any uh, schools in mind that you are targeting or you wanna go into around
Uh
robotics?
yeah, I was thinking like maybe my dream school is MIT. That's
Okay, okay, yeah, that's really nice. Definitely continue working on this project and uh, validate it. Like you can actually go to some uh, mentors, or you can find mentors. You can go to professors, and you can validate this product. And definitely you can you know test it with among your friends, see what they're saying. Maybe they have further ideas on how to add features on this. Do it, work on it, and spend some time. Give this product some time, and it'll definitely turn out to be exceptional. Okay, and this aligns with what you want to do, the things that you're interested in. So yeah.